Now for section 2.4, we're going to be doing applications of linear equations. So what we're going to be doing is solving word problems by setting up a linear equation. So it's going to look like something we've been doing in the past few sections, and then we're just going to solve it. So there's no direct way to go about these problems, but these steps here are kind of a good spot to start off. So the first step, obviously, read the problem carefully, determine what's given and what we're looking for. We need to assign a variable to what we're looking for the unknown value. Then we're going to set up the equation, solve the equation for the variable, and then state the answer. And then we can check the answer back in the original, and then we can also just sort of check the answer to make sure it makes sense. So let's do some examples of this. So the first one here, we have the product of 4 and a number decreased by 7 is 100. What is the number? So we have the product. The product means multiplication. So we're multiplying 4 times something. We're multiplying 4 by a number. So the number is going to be our variable x by a number decreased by 7. Decreased means subtraction. So we actually need parentheses around this. And a kind of a hint for why we need parentheses is because of this comma. And this comma also. So it's the product of 4, and then those commas are kind of like parentheses, and a number that was already decreased by 7. So we have 4 times x minus 7 is an equal sign. So is means equals, so equals 100. So the product multiplication of 4 and x minus 7 equals 100. So we want to know what that number is. So we're just solving for x now. So we need to distribute the 4. So we get 4x minus 28 equals 100. We need to add 28 to both sides. So now we just solve it like we've been solving it. And we're going to get 4x equals 128. Now we divide both sides by 4. So 128 divided by 4, it's going to give us x equals 32. So x equals 32. So that means, going back up here to the original question, 32 minus 7 gives us a number. If we multiply that number by 4, that should give us 100. Which makes sense because 32 minus 7 is 25. 25 times 4 is 100, so it all checks out. So the next one. So a little bit more of a word problem here. We have in the 2012 Summer Olympics in London, England, the US won 16 more medals than China. The two countries won a total of 192 medals. We want to know how many medals did each country win. Okay, so we have, I'm gonna set this up as x is going to be the number of US medals. And I'm going to say that y is going to be the number of Chinese medals. Number of China medals. So based on this, we know that they won a combined total of 192 medals, which means if we add x plus y, that equals 192. We also know that x, the number of US medals, is 16 more than China. So that means instead of x, we can write y plus 12. So instead of x for US medals, we let that equal China metals plus 12. Now we're going to solve this just like we've been solving them. So we're going to combine terms on the left-hand side. So we don't need those parentheses. We can drop them. So it's y plus y is 2y plus 12 equals 192. Going to subtract 12 on both sides. I'm going to go up here. So we get 2y equals 180 from the 192 minus 12. Divide both sides by 2. And we get y equals 90. So we need to answer the question. We need to know how many medals did each country win. The y here represents the number of China medals. So I'm going to go over here. So China won 90 medals. And the US won 16 more than that. So the US won 90 plus 16, so the US won 106 medals. I'm going to circle it because there's a lot going on over here. Okay, so what we did here is actually almost kind of something like the substitution method for what we'll be doing later on. Let's do the next one. So the owner of Terry's Coffee House found that on one day the number of orders for tea was 1/3 the number of orders of coffee. If the total number of orders for the two drinks was 76, we want to know how many orders were placed for tea. Okay, so I'm going to, once again, I'm just going to let x equal the number of tea orders. And I'm going to let y equal the number of coffee orders. So that means we know that x plus y equals 76 because it says the total number of orders it was 76. So we also know that the number of orders for tea was 1/3 orders of coffee. So what that means is that instead of the x, we can put 1/3 of the orders of coffee. So x becomes 1/3 of y, which means 1/3 times y. So now we have a linear equation with a fraction, so we can just solve this. So I'm just going to get common denominators here. So the common denominator would be 3 to combine like terms, which would make this second y become 3/3y because that's just equal to 1, but we needed a common denominator. So we add them together. 1/3 plus 3/3 equals 4/3. So that's 4/3 y equals 76. So we could divide both sides by 4/3. That's not the cleanest way to do it. The best way to do this is multiply both sides by the reciprocal. So remember that word reciprocal. Oops. That means we're multiplying by 3/4 on both sides. So that cancels it over here. And we are left with y equals 76 times 3/4. That is going to equal 57. So we have to be a little bit careful here. This is the orders of coffee. We're looking for the number of tea orders. So the number of tea orders is going to be 1/3 of that. So that means we have to do 1/3 times y, which is 1/3 times 57. That's 57 divided by 3, which equals 19. And that is going to be our answer. That is the number of tea orders. Okay, let's do another one. So a project calls for 3 pieces of wood. The longest piece must be twice the length of the middle piece. The shortest piece must be 10 inches shorter than the middle piece. If the board of 70 inches long is to be used, how long must each one of those 3 pieces be? So let's start this off here. So we know we have 3 of them, so I'm going to set it up. So the shortest, we have the middle, and then we have the longest. So let's figure out a way we can represent these with variables. So the longest is twice the length of the middle. So let's let the middle here be x, the variable x. We know the longest has to be twice of that, so that means the longest has to be 2 times x. We also know that the shortest must be 10 inches shorter than the middle piece. That means it has to be x minus 10. So shorter represents subtraction. Okay, so we also know that a total of 70 inches long will be used for the board. So that means the shortest plus the middle plus the longest has to equal 70. So what that means is that x minus 10, the shortest, plus the middle, plus the longest has to equal 70. So I'm going to drop these parentheses, we don't need them. So we just set up the linear equation here. So let's solve this for x by combining like terms on the left. So we have x plus 2x, that gives us 4x. So 4x minus 10 equals 70. We're going to add 10 to both sides and get 4x equals 80. Then we're going to divide both sides by 4. And we get x equals 80 divided by 4, so 20. So we got to be a little bit careful because what we solved for here was x. X represented the middle-sized piece. So I'm going to write a little answer key over here. So the shortest is x minus 10. The middle was just x. And the longest is 2x. So let's plug in x equals 20 for all of them. So for the shortest, 20 minus 10. So we get 10. And what was this in? This was in inches. Kind of running out of room here. For the middle, it's just x, so that's just 20 inches. For the longest, that's 2 times x, so 2 times 20, so 40 inches. Okay, so the shortest piece was 10 inches long, the middle piece was 20 inches long, and the longest piece was 40 inches long. Okay, so kind of introducing a little bit of trigonometry and geometry terms here, which you may remember. The terms supplementary and complementary angles. So before we get into those definitions, we just have to kind of define what an angle is. So an angle, the way that one common way to measure angles is using degrees with the little degree symbol, which I'm sure we're all familiar with. 1 degree is 1 out of 360 of a complete rotation. So there's 360 degrees in a complete rotation. So here are some other important terms. So 2 angles whose sum is 90 degrees are complementary angles. So if 2 angles add to 90 degrees, they're complements. An angle that is 90 degrees is a right angle. So only right angles are 90 degrees. 2 angles that add to 180 degrees are called supplements. So they're supplementary angles. And an angle that is 180 degrees is called a straight angle. So you can see down here with these diagrams on the left one, the leftmost one here, Angle 1 and 2 would be complementary angles because they form a right angle. And then for the middle diagram here, angles 3 and 4 would be supplementary because they add up to 180 degrees. And for the third one, we see that 180 degrees is a straight angle. Okay, so let's do a couple examples for this. Let's just do one example for it. So we want to find the measure of an angle whose complement is 5 times its measure. So we're going to let x here be the measure in degrees of the angle. So if x is the measure of an angle, we have to think about how can we represent the complement of the complement angle for that angle. We know that two angles x plus y have to equal 90 degrees if they're complements. So that means if we subtract x on both sides, that would give us y equals 90 degrees minus x. So that means the other angle here, its complement, has to be 90 degrees minus x. So this one is going to be the measure of its complement. Okay, so let's set up an equation. So the measure of an angle whose complement is 5 times its measure. So the complement angle, 90, I'm going to kind of ignore degrees for right now for the equation's sake. So it says the complement is 5 times its measure. So is why I put the equal sign here. The complement, 90 minus x, is equal to 5 times its measure. So 5x. So 90 minus x equals 5x. The complement is 5 times the angle. So let's solve this for x. So we're going to add x on both sides. We're going to get 90 equals 6x. Divide both sides by 6. And we end up with, I'm just going to write the x on the left side so it looks a little bit nicer. So 90 divided by 6 is going to give us 15. So this is actually going to be 15 degrees. Let's make sure we're answering the question. The measure of an angle whose complement is 5 times its measure. So that means the angle is 15 degrees. And its complement is 90 degrees minus 15 degrees, which is 75 degrees. So just found both of the angles. So one of the angles was 15 degrees and the other one was 75 degrees. Okay, so it looks like that'll do it for chapter 2.4.